Hi, in this video we're going to look at some examples of using product rule. So here on the screen you see a few different examples, and the first thing that we want to distinguish is which of these examples requires product rule. So remember that product rule is for finding the derivative of a product of two functions, right? So product, that's what we're looking for, two functions that are times each other. All right, and so in example 27 here, we've got 2x cubed times e to the x. So that is a product of two functions. 2x cubed would be one of the functions, and e to the x is another function. And then notice in 28, there we've got 5x squared minus 2x plus 1 over 3x squared plus 4. So that one's got division, so that one is quotient rule. We'll look at that in the next video. 29 is also division, so that will also be quotient rule. But then 30 is another one that has a product of two functions, and so that's another product rule example. All right, so once you've distinguished which ones use product rule, 27 and 30 on this screen, then you have to use product rule. So you want to be sure that you've memorized product rule. So product rule says derivative with respect to x of f of x times g of x is f prime of x, derivative of the first function, times the second function, g of x, plus the first function, f of x, times the derivative of the second function, g prime of x. All right, and so you can memorize that rule in different ways, but just need to make sure that it is a correct way to memorize that rule, and this is the way I will usually do it, starting by taking the derivative of that first function that I see in the product here. Okay, so if you've done product rule problems before, or if you're pretty good at keeping track of what you're doing, you might not need to write out some cues for yourself, but for these first few examples here, I am going to write out some cues. So I want to be sure that I label what I'm doing here. I'm finding dy dx, so I shouldn't write equals between the original function and whatever I'm writing down for the derivative. And I also should not just put it there with no label on that. Be sure that you're being good about labeling that. And I'm going to write some cues to myself down here below. So derivative of the first function times the second function plus the first function times the derivative of the second function. And you don't have to write those cues down there, but if you find yourself getting lost in the problem, that would be my advice, is to go ahead and write those things down. And then if you've written that down, then you're just kind of following the steps through the problem. So derivative of the first function, I want to find the derivative of 2x cubed. So the 2 is going to just come along, and then that's going to be times, I'm going to bring down the exponent and subtract 1, so 3x squared. Or if you're good at this and you've kind of gotten the hang of this a little bit, you could just write that as 6x squared. So derivative of the first function times the second function is e to the x, then plus the first function, 2x cubed, times the derivative of the second function. So derivative of e to the x is also just e to the x. That's that special function that's its own derivative. All right, so at that point I have the derivative, dy dx. That's what I was asked to find. If you're typing answers into MyMathLab, generally it's going to accept something like this that is unsimplified. However, if you ask it to show you answers, it will often show you answers in simplified form and sometimes in factored form. So that's perfectly fine as well. If you go ahead and simplify your answer and simplify it incorrectly, however, then it's going to be counted wrong. So if you do simplify answers, be sure that you're simplifying them correctly. All right, so a couple different ways that we could write this answer. I could write this as 6x squared e to the x plus 2x cubed e to the x. Sometimes in MyMathLab, they'll go ahead and factor out common factors, so you could do that as well. I have a 2 and an x squared and an e to the x that I can factor all or part of that out, and then think about what would be left when I factor that out. So either of those two other things that I wrote are perfectly acceptable ways to write your answer as well. On some of the written work for this week, it says that you do not have to simplify your answers, so what I put in the box would be perfectly fine to leave. Okay, 28 and 29 we said are both quotient rule problems, so we will do those in the next video. But let's go down here and try to find the derivative in this product. And again, I'm going to write some cues down here. The derivative of the first function. Now when I do that, we're going to chunk this term by term where the addition and subtraction signs are. I'm using the rule about adding functions when I find the derivative of this first function, and I'm going to go through term by term and find the derivative of each of those terms. So derivative of e to the x, that's its own derivative, and then minus derivative of x, I can think about that as 1x, so I'm using that rule for derivative of constant times x, so that's just 1. And then plus, and the derivative of 7, the derivative of the constant function 7 is just 0. Obviously I don't have to write plus 0 there, but it's okay to do that. And I went ahead and wrote it there just to remind you that I did take the derivative of that 7, and I got 0 from that. All right, so that's the derivative of the first factor in the product times the second. So I'm just going to write down that second function and that second factor. Then plus the first function. So that's just going to get written down, e to the x minus x, or 1x plus 7. And then times the derivative of the second function. So when I find the derivative of that second function, that's 3 terms in there, so I'm just going to go through term by term. So derivative of 2x squared, the 2 is going to just come along, and then derivative of that power, I'm going to bring down that exponent and subtract 1, so 2x to the first. Of course, the better you get at this, you'll just write 4x for that. And then the next one, that's constant times x. So derivative of constant times x is just that constant, 3. And then the last term there, the derivative of 4 is 0. So perfectly fine to leave your answer like this in unsimplified form. You can go ahead and leave off the plus zeros and write your answer like this. This is also perfectly fine to leave your answer like this. You can go ahead and multiply everything out, and maybe there are some like terms to combine if you really want to do that. I probably would not unless I was going to do something else with this derivative. The question of what is the best way to leave your answer probably has to do with why you're finding a derivative and what you're going to do with it next. At this point, we are just finding derivatives and writing them down. If you were going to do some other things with them, maybe you want to go ahead and multiply that, or maybe you want to leave it like this, and perhaps you're going to plug in a number for x, and then maybe you don't want to do a bunch of simplifying, you just go ahead and plug in your number for x. So depends on what you were going to do, whether you go ahead and choose to do all that simplifying or not. All right, next video we will look at those 2 quotient rule examples.